Okay, guys, welcome back. Let's go ahead and talk about this. If we're to find the sine of 120 degrees, what we first do is we find the angle here. We draw the angle of 120, and then we find you're going to like this, we find the reference angle. So basically, the sine of 120 degrees is going to be the sine of 60 degrees in this quadrant, in the second quadrant. So you remember how we talked about sine, um, the sine of any angle being y over r, where r was like the hypotenuse? Well, we're going to think about that here. So if this is 60 degrees, this would be 30. And so we're dealing with the 30, 60, 90 right triangle. Whatever value of x this is, we know it's negative. So this would be like some negative x value. And if that's the case, knowing the way that 30, 60, 90 right triangle works, this side would be 2 times that value. But the negative is just because of placement, not because of length. So really this is going to be a positive 2x, as this value here would be x root 3. What am I talking about? Well, if I had this as a point, the point would be negative x comma x root 3. Y over r would be x root 3 over 2x. What happens when I simplify that? I end up with the square root of 3 over 2. So the sine of 120 is the same as the sine of 60 degrees in the second quadrant, and it's going to be the square root of 3 over 2. Let's look at this next one. When we talk about cotangent, let's remember really quickly, cotangent is going to be x over y. X over y. We remember that from that little chart from before. Let's talk about how we can handle this. We first graph 7 pi over 4 to figure out what the reference angle is. And if you think about 7 pi over 4, I like to think 1 pi over 4, 2 pi over 4, 3, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Hopefully that makes sense. I know radians are new to us. So since we have that 7 pi over 4, we can see that the reference angle is pi over 4. And if you need to, sometimes it's nice to keep in mind what pi over 4 is in terms of degrees. And so pi over 4 is 45 degrees. So really, the triangle we're dealing with here is a 45-degree right triangle. Know that this value, well, let's actually think about this point. Whatever this value is, let's call it x. This value has to be the same thing, but because of its position, it has to be negative x. So the y value is negative x. This point would be x comma negative x. And so if I have to do x value over y value, that would be x over negative x, which we know becomes negative 1. I hope this is making sense. Guys, don't worry about it. If it's feeling uncomfortable, just wait till our live lesson so we can discuss again. It will all make sense. Example 5 is going to talk about quadrant and one trigonometric value. So we're going to start off with this. We are trying to figure out, we have an angle in standard position, and we're trying to figure out all of the 5 remaining trigonometric values if the secant of this angle that we're about to draw, if the secant of this angle happens to be negative 4/3. So I'm drawing the angle as best I can, putting the terminal ray in the third quadrant. And now I need to account for this secant value being negative 4/3. You remember what secant was in terms of the point, some point xy? Secant was going to be the reciprocal of cosine rather. And since cosine is I'm just messing it all up. Since cosine is x over r, secant is r over x. I promise I'm going to get this, guys. Okay, so secant is r over x. Keeping that in mind from that chart we had before. So if secant is r over x, then 4 has to be r, and it has to be positive because it's right there. And x has to be this negative 3. And so that's how we get r over x, or 4 over negative 3. We need to calculate this y value, right? The y value is going to be negative because it's positioning. And so don't be tempted to think this is the 3, 4, 5 right triangle. It's not, right? Because this value y is not the hypotenuse, and therefore it can't be the longest, all right? So negative 3 quantity squared plus y squared is equal to 4 squared, which is 16. So 9 plus y squared equals 16. Subtract 9 on both sides, we get y is equal to 16 minus 9 is 7. Sorry about that. Y squared is equal to 7. Therefore, y is equal to the square root of 7. So the fact that it's the square root of 7 is great, but the fact that the location is negative means that we've got to have the square root of negative 7, right? Negative the square root of 7. So now that we've got all three sides of the triangle, let's find those other remaining 5 trigonometric functions. So if we go by what we were talking about, we realize that x is negative 3 and y is negative the square root of 7. So we know that sine, and of course r, which is 4, we know that sine is y over r, and so therefore we have negative root 7 over 4. Cosine is the reciprocal of this, or it's going to be x over r, so it's negative 3 over 4, which we knew would be the reciprocal. Tangent is going to be y over x, so that's going to be negative root 7 over negative 3, which actually leads to just root 7/3, right? Root 7 over 3. And cosecant is going to be the reciprocal, so we'll get 4 over root 7. Cosecant is the reciprocal of sine. We're going to rationalize that denominator, so we get 4 root 7 over 7. Don't forget it's negative. And finally, our cotangent, let me scooch it down here because I've been jumbling everything together. Our cotangent will be the reciprocal of tangent, or it will be x over y. So that's negative 3 over negative root 7, which is going to be 3 over root 7. And if I rationalize the denominator, it'll be 3 root 7 over 7. All right? Okay, we have one more example for this section, and that'll be great. We'll be fine. So find the coordinates of a given, find coordinates given a radius and an angle. So we were given this value here of 4. Let's read the problem. In a robotics competition, a robotic arm 4 meters long is to pick up an object at point A and then release it into a container at point B. So moving from here to here. Good. The robot's owner programs the arm to rotate through an angle of precisely 135 degrees to accomplish this task. What is the new position of the object relative to the pivot point? So in a way, we're setting this up as if we are initial ray and terminal ray, but this time we're taking into account the length of that ray, which is 4 meters. So in essence, we want to know what the ordered pair is here for this particular situation. I'm going to just kind of gently drop down a coordinate axis so we can kind of think of it in that way. Well, if we have 135 degrees here, we know that the reference angle is going to be 45 degrees, okay? And so if that's the case, that's going to give us a lot of information on, what points are and what we have. So if we're dealing with a 45-degree angle, a 45-45 right triangle, we know some things here. We know that the x value and the y value, absolute values, will agree. They will have the same kind of value there. And we know that this 4 is going to help us know what that is, right? So if I know that this side is x and this would be x in the same way, let's see if we can calculate what that would be. So you remember that the side of a right triangle, of a 45-45 right triangle, is like x, and then the hypotenuse would be x root 2. And so we're going to play that out here. If the hypotenuse is x root 2, then 4 is equal to x root 2. And if that's the case, we're going to divide both sides by square root of 2. So 4 over the square root of 2 is equal to x. And therefore, we kind of finish this off by rationalizing the denominator. We get 4 root 2 over 2, which is really 2 root 2. So x is equal to 2 root 2, that generic x value that we talked about. But you know what? This is on the negative portion of the x-axis. So that's not 2 root 2, it's negative 2 root 2. And since this has to be the same value, that's going to be 2 root 2. And that is the location of this particular object from the pivot point. So if we think of this as an XY axis, that would be it. All right, guys, I feel like I am looking forward to talking to you guys so much because I know that there's a lot here to unpack. If we get to chat later on during the week, great. But if not, I'll see you the next time we get together as a class. And I look forward to some fruitful discussion. Take care.